So we are looking at section 4.4, part 2. And this is going to be all about how do we know how to completely factor a polynomial if they tell us one of the factors. That's what we're going to be looking at. A really helpful theorem to remember is the remainder theorem. The remainder theorem says that if a polynomial f of x is divided by x minus k, then whatever that remainder is, that's the same thing as if you were to plug in k to the function. All right, let me show you what we mean by that. So let's say we have this, x squared plus 3x minus 2. And let's say I do synthetic division of 1. All right, so I'm going to do 1. So I write this out. This would be 1, 3, negative 2. I bring down the 1. 1 times 1 is 1, add it. 1 times 4 is 4, add it. And I get 2. So what that tells me then is if this is my function right here, if I were to plug in the number 1, I should get 2. Let's see if that's true. What is 1 squared plus 3? 4 minus 2 is 2. So see how that works? So when I do synthetic division with the number 1, this right here is going to tell me what that y value would be if I were to plug in 1. So next we move on to the factor theorem. The factor theorem says that if f of x has a factor of x minus k, if and only if f of k equals 0. Again, x minus k will be a factor if when we do synthetic division with that k value, we get 0. Let's do an example and it will make more sense. Determine whether the binomial is a factor of the polynomial. Here's the polynomial, x cubed plus 3x minus 6. We can't even factor this with the methods that we know because we have x cubed here. So what we're going to do is we're going to think, what would make this equal 0? What is it? So I'm going to put 2 in the box. I use my coefficient of x cubed, that's 1. I use my coefficient of x squared, that's 0. Coefficient of x is 3, and then my last number is negative 2. And now I'm going to do the synthetic division. So we bring down the number 1, we multiply, we add, we multiply and add, we multiply and add. What does it say right here has to be our remainder in order for it to be a factor? 0. And we did not get 0. Oh, I see my mistake. I'm sorry. This should be negative 6, shouldn't it? I'm sorry. I glanced at that. That's a negative 6 right there. I just accidentally looked there. Sorry about that. Regardless, even if this is negative 6, negative 6 plus 14 is 8. Is it going to be a factor? Did we get 0 as the remainder? No. So it is not going to be a factor. Okay? Let's look at another one. It's saying to show that the binomial is a factor of the polynomial. Then factor the polynomial completely. So, what's going to go in the box? So negative 2 goes in the box. Look at your coefficients. 1, 2, negative 9, negative 18. Let's use our synthetic. Bring down the 1, multiply, add, multiply, add, multiply, add. We were supposed to show that it's a factor. Did we show that it's a factor? Yes, because the remainder was 0. So that shows that it is a factor. Now it says to factor the polynomial completely. This is my remainder, this is my constant term, this is my x term, this would be my x squared term. So after I divide by x plus 2, this is what I'm left with, x squared minus 9. Can we factor that down further? How? Difference of two squares would make it x plus 3, x minus 3. Yes. And so now showing the complete factorization for s of x, I would say that s of x is the same as x plus 2 multiplied by x plus 3 multiplied by x minus 3. That's the complete factorization. Any questions on that?
Yeah, where's the x plus 2 from?
The original, it told me that that's a factor, right?
Yeah.
So I had to include it. Now, guys, I want you to look at this for a minute. This original problem that we were given. Could you have factored that without doing this method? Look at grouping. Look at these two and look at these two. Out of these two, I could factor out an x squared, and I'm left with x plus 2. Out of these two, I can factor out a negative 9, and I'm left with x plus 2. So what can I factor out of this and this term? What do they have in common? X plus 2. What am I left with after I factor it out? Yes. And doesn't that factor down into this?
Yes.
See how it's connected? It's all related. Okay, let's look at the next one. Show that the binomial is a factor of the polynomial, then factor the function completely. All right. Let's do a more challenging one instead of number 1 or number 3. Let's skip on down here to number 4. So what's going to go in the box? 2. And now we're going to use our coefficients. 6, 8, negative 34, negative 12. I bring this down. I have 6. I multiply and add, multiply and add, multiply and add. So I got 0. That's how we show that that is a factor. If it's a factor, we have to get 0 for the remainder. So now I have to decide what this tells me. Well, this is the constant, this is the x, this is the x squared. So now I have to take 6x squared plus 20x plus 6. I have to factor that further. First, what is it that 6, 20, and 6 can all be divided by? So I'm going to take out a 2, and I have 3x squared plus 10x plus 3. I'm going to go ahead and do it the way I like to factor. I multiply 3 times 3, I get 9. Are there factors of 9 that will add to give me 10? 9 and 1. So that means I'm going to have 2, and I'm going to factor this. I have to get a 9 and a 1 with those outers and inners. I also know that this times this has to give me 3x squared. So I'm going to have to do 3x and x. With the outers, I have to get a 9 and a 1. So what's going to have to go here? 3 is going to give me the 9. What's going to have to go here?
1.
And now I have to check and make sure it works. 3x squared, that works. The last works. That's 9x and 1x, that works. Plus and plus. But that is not the complete factorization for f of x. F of x is going to be 2, and it's going to be 3x plus 1 and x plus 3. But what's the other factor? X minus 2, yes.
I was looking at the top.
Yes, I did the same thing. I know what you were thinking. So there we go. Does that make sense?
Yeah.
Okay. Let's do this last one because there's something I want to show you with it. What is it that we're going to put in the box? 5 in the box. Coefficients, 2, negative 12, 6, 20, and 0. You have to put a 0 there. Because there is no constant term. See how this has the constant term and this is missing the constant term. So you have to put the 0 there or your remainder will be wrong. Bring down the 2. I'm going to do this faster since everybody's getting the hang of it. 10, negative 2, negative 10, negative 4, negative 20, 0, 0, 0. Alright. We good?
Yeah, that was really
Well, you can do that too. This is our remainder. This is our constant. This would be our x term. This would be our x squared term. This would be our x cubed term. Guys, also, to figure out what this should be, you can look at it this way. We're doing 2x to the 4th divided by x. Isn't that going to be 2x cubed? So I can like double check that. Alright, so now I have this left. I have 2x cubed minus 2x squared minus 4x. What's the GCF, bless you? So we're going to have 2x, x squared minus x minus 2. Are there numbers that multiply to be 2 and subtract to be 1? Okay, so now we know f of x is going to equal, I just bring this along. Bring along your 2x. That's a factor. This one I'm going to factor down into x and x, 2 and 1, minus and plus. Now look at this. X times x times x is only x cubed, and I'm supposed to have x to the 4th. So what am I missing? Very good. There's our complete factorization. See how this can actually help us factor. It's like they're giving us one factor, we're finding all the rest. Alright, we're going to do a word problem here. During the first 5 seconds of a roller coaster ride, the function h of t equals 4t cubed minus 21t squared plus 9t plus 34 represents the height in feet of the roller coaster after t seconds. How long is the roller coaster at or below ground level in the first 5 seconds? Alright guys, let's look at it. Here's time 0. Here's time 5. I want to know how long it's below ground level. I need to know this point and I need to know this point, right? Because that's when it's going to be below ground level. Can I tell what that point is right there?
Yeah.
What does it look like? 2. So I know 2 then must be a 0. So I'm going to go ahead, I'm going to put 2 in the box because I know that's a 0. That has to be a factor. If 2 is a 0, then x minus 2 is a factor, and I'm not definite on that, so I'll show you on the calculator too, but for now that's what we think. We're going to see what happens here, because this is going to tell me for sure if it is a 0. I bring down my 4, that's 8, that's negative 13, that's negative 26, that's negative 17, and oh goodness, that is not a 0 there at 2. That's interesting. Okay.
Wait, no, it's next 34.
Oh, there we go. That makes more sense. But yep, that's 34 too, isn't it? Goodness. I'm going to need a new video. 0. Okay. So, that is a 0, like I thought it was going to be. At first I was wondering what was going on. Okay, so we got that 0. So now I can take this and I'm left with 4t squared minus 13t minus 17. Now I can factor that, hopefully. We'll see. What is that? 34, 68. Are there factors of 68 that will give me 13? I don't know. 34 and it's 34 times 2, 17 times 4. Yeah, 17 and 4. Yeah, there we go. Okay, so then that means I'm going to need a t and a 4t and a 1 and a 17 and a minus and a plus, and so t would have, I'm going to set these equal to 0 now, so t equals negative 1, or 4t minus 17 could be 0, so 17/4. That's good. Because that tells me now that that point has to be at 17/4. This point is at 2. So if I want to find out the answer to this question here, how long is the roller coaster at or below ground level? It's between 2 and then what would that be? 4.25? So for 2.25 seconds. Okay? Alright, so now, what is the height when the ride begins? These are different questions. Estimate it, guys. What's the height when the ride begins? You can actually know it exactly, though, because what would I plug in for t at the beginning of the ride? So what is it? Yep. I know. It doesn't look like, it's not drawn very well to scale. What is the lowest point that the roller coaster goes? Right about there. It's hard to tell. So what would we have to do if we really needed to know that exactly? As you can see, since I'm going to my calculator, can we find the exact minimums on our calculator? I'm going to have to change my window too. I know we're running short on time. Okay, so I'm going to have to change my window. This window is going from like a minimum of maybe negative 60 to a Y max of maybe 120. Let's see if that makes it better. Alright, and then it asks me how low it goes, so I need that low point. So second trace, calculate minimum. Get over there close to it, but I have to be on the left of it, on the right of it. And right there is the minimum. What is that? 21.26. Below ground. Okay, that's not too far down below ground. What is the coaster's height at 5 seconds? I'm going to use this. Second trace to get to my table. What am I looking for? A t value of what? 5. I could also use synthetic division, but why? Why do you think h of t is not an accurate function for the entire time the coast is traveling? Anybody have ideas on that?
Oh, because it wouldn't just be like going like this the whole time, like the roller coaster is like chasing us.
Right. What were you going to say, Riley? Yeah, this coaster keeps going up and up and up. It never comes back down. I don't want to be on that coaster.
I know. How does the roller coaster go below ground?
Oh, they do that. At Kings Island, don't they have one that goes underground?
Which one?
Was it Flight of Fear, maybe?
No, that's inside.
Well, it's inside, but I think, don't you start off by going down and then you come back up, I think?
No, you go straight and then go down.
I'm sure there are roller coasters that go below ground. I don't know. We can research that.